Hello friends, welcome to Shiksharthi. In this session, we shall be discussing rational inequalities. So let's start. Now, as always, we set the parameters for a session, and here the prerequisite for this session on rational inequality is functions and numbers. That means you should have a fair enough idea about what functions are, what are the investigative parameters of a function, and thereafter numbers you should have a holistic view. Okay, going ahead, we are going to discuss two different types of rational inequalities when we are talking about real numbers. So here you would see that fx and gx are two real number functions, such that the first inequality that we are going to talk about is fx divided by gx greater than 0, and the second one is fx divided by gx lesser than 0. As talked about during our session on functions, before we do any mathematical operation on a function, we need to specify the domain of the function. So if I say fx divided by gx, what is a mathematical operation that you're doing on a function? You're dividing fx, you're forming a composite function. You are having a combination of functions, which is fx and gx, and the combination here is facilitated by an operator of division. So if I were to understand it like this, if I say that there is a function phi x which is defined as fx divided by gx, what is a mathematical operation that we are performing on the functions fx and gx? We are dividing fx by gx. So the very first thing that we would do after this is the first thing. You would specify the domain of fx. You would specify the domain of phi x. So the domain of phi x is nothing but domain of fx intersection with domain of gx, and along with this, gx should not be equal to a 0, which comes as an additional domain constraint. Why? Because please try and relate, when we talk about real numbers, what are real numbers? Any number which is written in the form of any real number that is written in the form of p divided by q, such that q is not equal to 0, and at the same time both p and q are integers. Okay, so this is the first thing that you're gonna do. So the domain of phi x needs to be specified, which is nothing but domain of fx intersected with domain of gx, union with gx should not be equal to a 0. Okay, what is the second thing now? So once you have specified the domain, now we are restricting the range of phi x, which is phi x is greater than 0. So when phi x is greater than 0, so please try and understand it like this. If I divide a positive number with another positive number, it is then the outcome that we get is a positive number. Second case is if I divide a negative number with a negative number, it is then that we get the answer as positive. So what we are doing here is we are dividing the basic inequality into two parts now. One is when the numerator is positive, so you would say that fx upon gx will be positive only when both of them are positive. Or both of them are negative. An intersection with domain of phi x in both the cases. So you're taking the domain of phi x in both the cases. Now when you are writing three different things on one after the other, that means you are supposed to take the intersection of all the three. You are supposed to take the intersection of all the three. So when you have written this, you are supposed the final answer or the solution. So the solution here would be when you would take the intersection of all the three. So the solution set is the intersection of all the three. Now the same thing we would do here on the other side when we are talking about fx being lesser than fx upon gx being lesser than 0. The very first thing that you are supposed to do here is domain of phi x is what you need to specify. So the domain here would be, so domain of phi x is nothing but domain of fx intersected with the domain of gx, and along with this, which is you are saying union, you will say that gx should not be equal to a 0. When you have specified this, then the next point that we would make here is, we know that if I divide one number by another number such that the result should be negative, this is possible only when I take the numerator as positive, the denominator as negative. It is then we get the answer as negative. Or we take the numerator as negative and the denominator as positive. It is then also that we get the answer as negative. So you will make two cases here, which is just like saying the numerator is positive, the denominator is negative, right? And then you need to know the domain so we have the domain also, which we know that the domain of phi x is nothing but domain of fx intersected with domain of gx, union with gx should not be equal to a 0. And then you take the intersection of all these three. The second case here is when the numerator is negative, denominator is positive, and we take the intersection of both of these with the domain of phi x. And what is phi x here? Just for the sake of understanding, though we have already discussed, phi x is nothing but fx upon gx, which needs to be lesser than 0. And then for the final answer, which is the solution set to this inequality, the solution set would be nothing but the solution set is their intersection. Their intersection means the intersection of all these three, and on the other side 1 2 3, and on the other side 1 followed by 2 followed by 3 is their intersection. Now the point which arises here is, why are we taking the intersection? Because we are interested in getting the values which are common to all of these, not the uncommon one, which is why we are taking the intersection. Hope you have understood the basics of the rational inequality, the type of rational inequality that we talked about, so that you can take your learnings to the next level.